Alright, for a special request, I'm now curving the laser concentric, more or less, to the curved fiberglass stake. So, as you can see, we have our normal setup here with our little lights on Candle Mountain. You can control the brightness right here. And I have a little laser set up so I can kind of aim it. And you can see the laser beam goes, see, right about here, and right into the tank there. Goes along this curved highway. It's actually a fiberglass kind of roadside marker stake that was busted and thrown in my yard about a decade ago. And so I cut the good part out and put that rope across the bottom to make it bowed like a archer's bow. And now that's my curve. So you can see my laser is curving right along the stake. It took me some effort to keep mixing the gradient until I got it just right so the light curved equal to the stake. But you can see, I'll just go along here. Moving towards the source, so you can see the laser's getting a little thinner. Here to the input end, where it then comes in through the glass. So from top down, you can see I've got it right there on the left edge, because I got some plans for this setup here, other than the laser as well. And I wanted the laser as close to this near glass as possible, while still being where the curved archway is, because to get a good view of what the laser path is doing, we want to be looking at it through as little refractive gradient as possible. So like, if I were to go to the other side, see, we would get like kind of weirdness and stuff, because we're looking through more gradient. And I hope to do a video on that as well, showing the side effects. Oh, this is interesting. So while we can see that this laser is curved, it is physically following the curved stake, and if we were to take and put say a dime in there or something, it would block the beam. So we know that the beam is physically in that location, because that's where we would put a dime to block it. But look what happens when we look at this laser beam from the same path as it's going. I'm getting right beside the laser, just about the same height. Oops, I just cut off the laser. Okay, I'm right like beside the laser. You can see that the laser beam appears, okay, right there. It appears straight now, even though we know it's curving, but because we're looking at it through the same gradient that's curving it, the light reflecting off of each of those little bits of dust in the water is also being curved along the same path, causing it to appear straight. Now if we go below it, it appears to curve up. If we go above it, it appears to curve down. And so there you go. When you're looking at a glowing laser beam from the same location that it's being sent from or sent to, even if it's curving, you're still going to see it as straight if you're looking at it through the exact same gradient.